Hey, welcome to the NextDrop Question. I'm Mohamed Ateia. This is a short conversation series where I ask one focused question to experts working at the front lines of water, contaminants, environment, and practical solutions. Hello from Houston. I am at Rice University, today attending the International Water Association Leading Edge Conference on Water and Wastewater Technologies. I'm here with Menachem Elimelech, and we will be talking about the practical side of water innovation. So a lot of conversations in our field start with technologies, but the harder question is often how those technologies fit into real systems, real constraints, and real decisions. We'll be talking about what makes a solution useful, what slows adoption, and what practitioners should pay attention to. So let's get to it.
Okay, so can you tell us, how are you and what are you doing now? I know you changed affiliations quite a bit.
Okay, so I'm Menachem Elimelech. Meni is my nickname for Menachem. I'm a professor now at Rice University. I moved here in January 2025 after 25 or 26 years at Yale University, where I founded the environmental engineering program. So
yeah, I mean, I think when I think about people who made a big impact on their specific area, you literally jump to mind immediately. Just consistent progress. And I guess that's part of the theme that you talked about it today, about how can we allocate resources when it comes to R&D work to go to more productive direction. And I guess you show that by example. So can you tell us about like how things have been over the past 20 years in the field from your point of view?
Well, it's a very broad question. Again, I work on all aspects of membrane technologies for desalination, water reuse, resource recovery. But I always try to analyze the process more in depth, because there is a tendency for many researchers to jump in. They don't look at the thermodynamic limits, efficiency, and they just jump in and get excited and then move the field. But sometimes you can just take a minute aside and think carefully about the process. I mean, what are the limits of this process? Will it be viable under this condition? So I like to do these kind of things, and I've done it for several processes, even after working with them. And after working with them, I realized that something is missing there. And when I did the analysis, I arrived to many, many interesting conclusions. One of them, in the talk today, I talk about the jump for ultra permeable reverse osmosis membrane.
Yeah.
Everyone was jumping into it and making a big deal, and there was a lot of funding. But as you've seen in my talk today, once you do the analysis above a certain permeability, there are no benefits for the energy consumption,
Yeah.
It's just one example, yeah.
And that's the great thing about just knowing the pain point of an industry and try to think about a simple solution. Actually, the simple solution is very hard to get, but I think you are showing by example that you can get there once you set a correct right of priorities, right, in the questions that you start from.
Yeah.
Because following a hype can be easy.
Yeah.
But actually making a solution that can be scalable, I guess you showed the example of, the same templation or polymerization method.
Yeah,
for conventional polymers, you can just make a simple tweak and you can get better performance. That can be both.
Yeah.
Performance is better, but also the scalability is there. So
to be honest, in my career, I also jumped to many heights. But after a few years, when I got deeper, I realized that something wrong. And then I stood up and spoke about it and wrote about it. And you heard about several examples today for ultra high permeability membranes.
Yeah.
But also all these graphene membrane, and I showed you by simple analysis that they did the way they designed the graphene, it will never be better than the current membranes.
Yeah.
I also challenged so many other things in my career, So it's very important to be critical again. And again, my goal is not just to be negative on everything, but eventually it's a taxpayer money, and we need to be careful, Of course, you can use the money to train graduate students, which is very important and so on. but up to a limit. You cannot extend the non-truth of it. I don't want to say a lie and keep working on it, knowing that this will never work. But I'm getting money and I'm supporting my students.
Yeah.
You do it up to a certain point, and then.
So now you have you're leading a new center here at Rice.
Yeah,
focusing on membrane. So what is next? What are the major directions that you're going after?
So again, we just established the Rice Center for Membrane Excellence, and my goal is really to cover all aspects of membrane research, from the molecular scale theory all the way to pilot. So we just built testbed facilities. Too bad you cannot see them in a Ryan building. And we are trying to establish connections with the industry. We are soon to get a contract from the IDE Engineering, very prominent desalination. A lot of the local Houston company are interested. So I'm really interested to eventually solve real problems, after so many years of doing fundamental research. But again, I also keep the fundamental research going. It's very important to understand everything from the molecular scale to the, pilot to process scale.
Yeah, the translation of science, I guess this is where most of the focus should be going moving forward. Yeah, as you said, we're not abandoning basic science. It's still needed.
Exactly.
Challenges that are still either emerging or anticipated. So having that framework of translation, I guess, is very impactful. So again, thanks again for everything that you're doing.
My pleasure. Yeah.
Thanks for your time. And
thank you so much.
Very nice catching up with you.
Thank you.
That was the NextDrop question. Thanks for listening. See you next time.